Hello everyone, I hope you guys had a great spring break. We're going to start back up with factoring quadratic equations to solve them. So we're no longer just factoring, we are going to factor and then solve them. So the difference between a quadratic expression that we were factoring before spring break and what we are doing now is that now they're set equal to 0. So what do we need to remember are the steps to solve a quadratic? Well, we need to remember that we need to get two factors that end up adding up to our middle term. Sometimes we can factor by grouping, and we can also factor by bottoms up method. And that means if we have something in front of our x squared other than 1, that means that we are going to need to actually multiply and factor by grouping or factor by bottoms up method. I typically use the bottoms up method, but if you like factoring by grouping, you can do that as well. It does not matter to me. How many solutions should we have for each quadratic? Well, typically you have 2, and the reason for that is because it is x squared. There are going to be times when the solution is actually the exact same for both parts, or sometimes neither of the solutions end up working, so we call that no solution. But for right now, we're going to have 1 or 2 solutions. The solution, when we are talking about it to any quadratic, is what we call a root. So if you remember the solution to a quadratic, it's called a root. Sometimes instead of saying factoring to solve the quadratic, it'll say solve the quadratic or find the root or find the roots. So to start off with example 1 here, we see that we have an a number in front of our x squared term that is not 1. So that means we're going to have to factor by grouping or by bottoms up. So I'm going to do the bottoms up method, which means we're going to take our a term and we are going to multiply it by our b term. So when we do this, we get 3 times 4, which is 12. So now we need to figure out factors of 12 that end up adding up to our b term, which in this case our b term is 7. So the two factors of 12 that add up to 7 are 3 and 4. So we end up having x plus 3 and x plus 4. It doesn't matter which one comes first. So if you want to do x plus 4 and then x plus 3, completely fine. Remember that it's always set equal to 0 because we're solving this. Also, once we have our two factors decided, 3 and 4, they multiply to give us 12, add together to give us 7. So then we're going to divide by our original a value, which in this case is 3. So when we simplify the first one, that becomes x plus 1, or 1 over 1. And the second one, we can't simplify at all. But what we can do is the bottoms up. So we're going to bring this bottom up. So that means that we have 3x plus 4, and that is equal to 0. So now the only thing that's different that we haven't done yet, we've already figured out how to factor. We knew that. We did the test before spring break. Now we're going to set each of these factors equal to 0 and solve them. So our first factor is x plus 1 equals 0. We're going to subtract 1 to both sides, which ends up giving us x equals negative 1. Oops, negative 1. So that is one solution. Our other solution is going to be 3x plus 4 equals 0. We'll subtract 4. And then we are going to divide by 3 on both sides. So that ends up giving us negative 4/3. So our two solutions are x equals negative 1 and x equals negative 4/3. But you can go ahead and put them together and separate them by a comma. Now remember, with our solutions, we can always check whenever you're solving an equation, you can always plug it back into the original problem. So if we plugged in negative 1, for instance, in for x squared and x, we would get negative 1 squared is 1 times 3 is 3. 7 times negative 1 is negative 7. So 3 plus negative 7 is negative 4 plus 4 is 0. So it ends up working. And then we could also do the same thing for negative 4/3. It's just I'm not going to do that at this time. All right, so here our second example. We have 4x squared minus 12x plus 9. Now, this is called the perfect square method. Both of 4 and 9, so our a and our c term, are perfect squares. If you didn't notice that, you can end up doing the bottoms up method and you will get the exact same answer. But because they are the exact same value, with the middle term being a negative, if we took the square root of our 4x squared and the square root of our 9, we end up getting 2x minus 3, and we have 2x minus 3. And we know that they both have to be negative 3 because 2 times negative 3 is negative 4, 2 times negative 3 is negative 6. So negative 6 plus negative 6 will give us that negative 12 term in the middle. Again, both of these are set equal to 0. But because they are the exact same thing, we only need to solve it once. So we add 3 to both sides, and we get 2x equals 3, and then divide by 2. So when we solve this, we end up getting x equals 3 over 2, or 1 1/2, and that's our only solution. It's still technically 2 roots because the 2 roots are the exact same. Okay. Again, if you wanted to do bottoms up method on this, you could have 4 times 9 would give you 36. Factors of 36 that add up to negative 12 are going to be negative 6 and negative 6, because negative 6 times negative 6 gives us positive 36, and negative 6 plus negative 6 gives us negative 12. Then we divide by the original 4, simplify, and do our bottoms up method. All right, so here with example number 3, this one's a little bit easier. This is called our difference of perfect squares. We notice 9x squared is a perfect square, and so is 81. So if we take the square root of both of these, this would be 3x plus 9, and then 3x minus 9. Remember I said this is the difference of perfect squares. So if you look right here, it is a subtraction sign. So plus and minus would end up canceling out our middle term. So if we were to FOIL this all out, first outer, inner, last, we would end up getting 9x squared minus 18x plus 18x minus 81, which positive 18x minus 18x is going to give you the exact same thing. Now, these are the exact same solutions. So these are not the exact same solutions. So since they're not the exact same, one's positive, one's negative, we're still going to solve it as 3x plus 9 equals 0. And then 3x minus 9 equals 0. They are different because one's positive, one's negative. So we'll subtract the 9, and then we are going to divide by 3. And then over here we add 9 to both sides, and then we divide by 3. And here we get positive 3. So our solutions are negative 3 and positive 3. Had you realized that you could have factored out a 9 from the very beginning, you would have been left with x squared minus 9. So then you would have had x minus 3 and x plus 3, which would still give you the exact same answer. All right. This last one here. This one is not set equal to 0. So since it is not set equal to 0, what we need to do is move everything to the left side so that it is set equal to 0. So instead of adding positive 3, we are going to subtract positive 3. And then that'll give us 15x squared minus 3a minus 3 equals negative 7a. Now I'm going to add 7a to the negative 3a. So this gives us 15x squared plus 4a minus 3 equals 0. All right, so now we notice that the term in front is 15, so it's not a 1, which means that we are going to need to multiply our a by our c. So when we multiply 15 by negative 3, that gives us negative 45. So when we have factors of negative 45, we have to figure out what two numbers that when multiplied give us negative 45, but add together to give us positive 45. So if we look at this, we have 9 times 5, but if it was negative, that would be 45. And if we do 9 plus negative 5, that gives us positive 4. So that does check out. We do 9 times negative 5 is negative 45, and 9 plus negative 5 is positive 4. So our factors are x plus 9 and x minus 5 equals 0. Again, I'm using the bottoms up method, so I'm going to divide by my original a, which is 15. And then I'm going to simplify both of these down to x plus, I can divide both by 3, so 3/5, and x minus 1 over 3. Now I'm going to do my bottoms up method, so bottom up. I now have, oops, I said 3, 5x plus 3. That's our one factor, and I'm automatically going to set it equal to 0 since I know I need to do that. And then the other one will be 3x minus 1 equals 0. Okay, so now I'm going to simply subtract 3 here, and then divide by 5. So now I get x is equal to negative 3/5. And over here I'm going to add 1, and then divide by 3. And I get x is equal to 1/3. So my final solution is negative 3/5 and positive 1/3. The order does not matter. It's really up to you to decide. Now, you can plug these back in like I've said from the beginning and check that they work. I just know you guys in fractions aren't always the best, so that may not be something that you're wanting to do. Okay. So our last and final example says the height of a flare fired from the deck of a ship in distress can be modeled by h equals negative 16t squared plus 104t plus 56, where h is the height of the flare above water and t is the time in seconds. Find the time it takes the flare to hit the water. So we have to remember that when the flare hits the water, it is at 0 feet above sea level. So 0 is going to be our h value. So instead of h, I'm going to plug in 0. And then I'm going to have negative 16t squared plus 104t plus 56. And we know that this is a quadratic. It ends up being a U-shaped graph or an N-shaped graph. And it's a parabola, which means it goes up. When you fire a flare into the sky, it goes up, and then it arcs and comes back down. So it hits its highest point and then comes back down. So that's why there's a negative 16 instead of just a positive 16 squared. Now, all we have to do is solve. Now, these numbers are very big. I'm going to try to find out if 16 goes into all of them. And okay, so it doesn't go into 56 evenly. But I do know that 8 goes into negative 16, and I know it goes into 56, so I'm going to check. Does it go into 104? And yes, it does. So I'm going to divide by my greatest common factor of 8, and I'm actually going to divide by a negative 8. That way, my first term is positive. You could divide by just regular 8, and you'll still get the same answer. So negative 16t squared divided by negative 8 is 2t squared plus 13t. Oops, sorry, that's going to be a minus 13t because we're dividing by a negative. And 56 divided by negative 8 is going to be negative 7. All right, so now what I'm going to do is I am going to multiply my 2 by a negative 7. So when I do that, that gives me negative 14. And my two factors of negative 14 that add up to negative 13 are negative 14 and positive 1. So now my factors are my negative 8 out front from the very beginning. I have to keep that. Then I have x minus 14 times x plus 1. And again, remembering this always equals back to 0. Next, what I'm going to do is I'm going to divide by my a value, which in this case was 2, because it's from that step that I have factored out my greatest common factor, not the very beginning, negative 16. So when I do that, this simplifies to x minus 7, and this is x plus 1/2 equals 0, and I leave the negative 8 out front. Now I'm going to do my bottoms up method. So now my final factored is x minus 7 and 2x plus 1 equals 0. All right, now I have to set these all equal to 0 and solve them. So if I do negative 8 equals 0, I hope at this point in math you know negative 8 is never going to equal 0. So this one's just not possible. So it's not even a true solution. I really don't have to do anything with it. The second factor I have is x minus 7 equals 0. So I'm going to add 7 to both sides. And when I do that, I get x equals positive 7. So that is a possible solution because my actual question is asking me, find the time it takes the flare to hit the water. So this would be 7 seconds. And then my last one of 2x plus 1 equals 0. If I subtract 1 and then I divide by 2, oops, I did not mean to do that. There we go. All right, so I get x equals negative 1/2. And if we remember anything about time, time cannot be negative, so it can only be positive. So our only solution in this case is 7 seconds. Okay. So if you guys have any questions, remember to email me, contact me. Today there isn't actually an assignment. Tomorrow there will be an assignment using these notes. I highly advise you to record your own notes, actually handwrite them either on paper or do a dual screen so that you can actually do your notes on paper and on your iPad, whichever way you would like to do that. I hope you have a great day.